Channel 262 News. I'm Joe.
And I'm Emma. Today we're talking about the glorious interworkings of digestion.
According to a recent GroupMe poll, 1 in 5 Purdue students did not know the bare bones basics of digestion.
Here we have live footage of their dumbfounding responses featuring Abby out in the field.
I'm here live with my new friend Dylan to ask some insightful questions. Dylan, do you know where digestion begins?
No, but I just invested $500 in Bitcoin.
Okay, well, it actually begins in the mouth with the enzyme called amylase found in your saliva. You may have thought it begins in the stomach, but this is a common misconception.
Yeah, that's cool, bro.
Well, I have one more question for you. Do you know what chemicals released in the stomach to break down food?
You think my traps look big?
It's called gastric acid, which is a digestive fluid composed of hydrochloric acid, potassium chloride, and sodium chloride. The acidic nature of this fluid has the capability to break down food.
Yeah, I think my traps actually do look pretty good.
Maybe you could help me.
Yeah, what's up?
I'm doing a new segment for Channel 262. Do you have a couple minutes to answer some questions about digestion?
Sure, I'd be delighted.
Okay, first question. Do you know how acid helps break down the food we eat?
Actually, I do. Doesn't it help to denature proteins and break down macromolecules we eat through hydrolysis?
Wow, you really know what you're talking about. Do you have time for one more question?
I don't actually. I have to get to class, so I'll see you
okay.
later.
I don't go to class, so I could probably sit down.
Okay, that's all the time we have. Thank you so much, Dylan. Stay in school. Back to you, Joe and Emma.
Okay. With that, we will be right back after the short commercial break.
Have you ever felt heartburn or had an upset stomach? Boy, do I have the product for you.
Tum.
Tums work fast and effectively to relieve stomach pain. The reaction behind this magical product is simple. Here I have a glass of vinegar to symbolize the gastric acid in your stomach.
Possible side effects may include constipation, nausea, vomiting, and a failing grade on your Chem 262 Real Life Orgo project.
The Tums are primarily made of calcium carbonate, which neutralize the excess acid, relieving the upset stomach you may have. Behind me is the chemical reaction. The great thing about this product is that it creates a buffer solution in your stomach to balance the pH, eliminating the sour feeling in your stomach. Buy Tums today, available at 3rd Street Market. Introducing new Kirkland almond milk. Most people are able to digest lactose, a component found in milk and dairy products. However, for some, the production of lactase is genetically limited. Lactase aids in the digestion of lactose, which is decomposed via lactase and hydrolysis, which splits into galactose and glucose. So for those that are lactose intolerant, try the new Kirkland almond milk. It still contains all the calcium and vitamins from regular milk, but contains no lactose. Find it at your local supermarket today.
This just in, avocados are taking the world by storm.
We have the following home video to illustrate just how enamored people are by avocados.
Avocado! Thanks!
We have a special guest joining us here today, Dr. Hall, who is an expert on digestion. Doctor, thanks for joining us today.
Thanks for having me.
Dr. Hall, we've seen how people have become fascinated with these avocados, but they also have a lot of health benefits, don't they?
Yeah, actually, they contain some really healthy fats and vitamins that are really good for your body.
You mentioned fats and vitamins. Could you take us a little bit deeper on how bodies digest those nutrients?
Yeah, sure. So avocados can be broken up into like 4 nutritional categories. So you have your proteins, your carbohydrates, your fats, and your vitamins. Each category of nutrient is digested and absorbed by the body in a slightly different manner, but each nutrient shares a lot of similarities with the others. Each nutrient, for example, begins to be digested as soon as it hits the mouth. It undergoes a similar chemical reaction, and they're all absorbed by the body in the small intestine.
Okay, interesting. When does the body start digesting these nutrients?
Yeah, so like I just said, the body actually starts digesting these nutrients in the mouth. So in your mouth, in your saliva, you contain an enzyme called amylase that begins breaking down the molecules in your food as soon as it hits your mouth. From there, your food is carried down to your small intestine.
Interesting. Okay. You mentioned fats earlier. How are the fats in avocados broken down and digested?
Yeah, so in avocados, fats are a really big deal. They contain a lot of monounsaturated fats, which are the healthy fats that I previously mentioned. These fats come mainly in the form of triglycerides. In order for these triglycerides to be digested, they first must be emulsified, which is the process of mixing two liquids that normally don't mix. This is done using bile acids, which can mix with both water and triglycerides. Once these bile acids attach to the triglycerides are now more soluble in water, and these triglycerides undergo a hydrolysis reaction. I actually brought my lab assistant here, Joey, who's been doing a lot of research on this subject recently. Joey, could you explain to the audience about this reaction?
Okay, so I'm going to be going over the reaction to form oleic acid a little bit more and how that is evident in digestion. So, like we said, we're going to start with the triglyceride molecule. This is like a big biological molecule that is pretty much a glycerol derivative. So this part here is the glycerol with the oxygens and the C's here. And then this part here are the 3 separate fatty acid chains. So each of these fatty acid chains contains an ester functional group, which is going to lead to the reactivity of this molecule in digestion. So we're going to be looking specifically at oleic acid, which has a structural formula of C18H34O2. The R group for the triglyceride molecule here is going to be this long chain. If you notice, this long chain has a double bond, which means that it is an unsaturated fat, a fat that is more healthy for you. Okay, now getting into the mechanism for this reaction. Like we said, we're going to start with our triglyceride molecule, and one of these carbonyls in the fatty acid chains is going to react with the free protons in the gastric acid in your stomach. So what's going to happen is the electron pairs on the oxygen in the carbonyl are going to donate to one of those protons. And what happens there is we're going to make an oxonium ion here. So from this, we can make a resonance structure where this double bond contributes to the oxygen, which gives us a carbocation. So now we have a carbocation which has been activated by the acid in your stomach. So what happens is we can have water add to the electrophilic carbocation, which makes this other oxonium ion intermediate. So that will occur like so. The lone pairs on the oxygen in the water will donate to the carbocation. From there, we're going to have the lone pair on the oxygen in the fatty acid chain. We're going to have that take a proton from the water that has just added. So from there, we're going to do a proton hop, which is the process that just occurred. So we're going to get this other oxonium ion intermediate. What happens now is how we form the oleic acid. So we're going to have the lone pairs in one of the alcohol groups donate to the bond with the carbon, making a double bond. And then this bond between the carbon and the oxygen that was originally in the ester is going to donate like so. So this bond is going to break. So now we have 2 separate molecules. We have almost our oleic acid, and then we have a diglyceride, because now we have an OH instead of another fatty acid chain. So from here, we're just going to abstract a proton. This is just the reformation of our acid catalyst. So what happens is this hydrogen leaves, and the lone pair, or the electrons in this bond, go to the oxygen, which gives you a stable carboxylic acid, which is our oleic acid. So this is actually why a lot of people end up having an upset stomach due to overproduction of gastric acid, because the acid is reformed in this reaction. So if your body continues to release this acid, then you're going to have a buildup, which is going to give you an upset stomach over time. So from this, our diglyceride molecule is going to go through this whole mechanism again and make a monoglyceride and one more molecule of our oleic acid. Wow, that was some really incredible chemistry. Well, thank you for that insightful lesson on digestion, Dr. Hall. That is all the time we have for now, and thank you to yourself and your lab assistant again for joining us today.
The pleasure is all mine.
That's all we have for today. Thank you for watching Channel 262 News.
We hope you enjoyed the glamorous content on the digestive system. Please make sure you join us next week when we discuss an even more invigorating topic within the world of chemistry.